Okay, in this problem here, we want to write an equation of this parabola, and we want to write it in vertex form, standard form, and factored form. The order doesn't really matter so much. Really, we're just looking at what is the easiest to start with and what we can put together with this thing. One thing that we do know that's in common between all three of these, we've got lots of constants floating around. In vertex form, we've got h's and k's. Standard form, we've got a's, b's, and c's. Factored form, we've got R's and S's or R1 or R2 or however you denote those roots. But one thing that's all the same is they have the same A value. So once I find that once, I really have found that for all three forms. So that's kind of nice to use to our advantage. So let's start with vertex form since I can clearly see what the vertex is. The vertex is 0, 1. So that what I know so far about vertex form is I know it's going to be in the form y equals a times x minus h squared plus k. And I know that the h and the k is the x and the y of my vertex. So this is like saying y equals a times, well, this is an x minus 0 squared plus 1. Or more simply, y equals a times x squared plus 1. So the last thing I need to figure out is what this a value is right here. And there's a couple ways you can do that. I could do that algebraically. I could take another coordinate and I could substitute it in for x and for y, and I could solve for my a value. But what's nice is in some cases like this one here, you can actually just identify by looking at the graph what the a value is. And the way that I'm going to do that is I'm going to go to my vertex and I'm going to go over 1 unit in the x direction and then see how far down I go in the y direction. Or I guess it could be up or down, but down in this case. Because I'm going down 1 unit, that means that I'm going to have an a value of -1. If you recall, normally in a quadratic, your pattern is to, from the vertex, go out 1, or I guess if we started down here, it would go out 1, then up 1, then out another 1, then up 3, then out another 1, then up 5. We have that step pattern of 1, 3, 5, 7, as we call it. And so what we can do then is if we look at whatever the first step is after going out 1 unit in the x direction, it's really important that you go 1 full unit, that's going to give us what our a value is. So in this case, a looks like it's going to be -1. So that means that this a is going to be a -1 here, and I'm ready to put my final vertex form all together. Let's go with y equals -1 x squared plus 1. And that's my vertex form. Done. Next is standard form. Or another way of writing this, I could write this as y equals -x squared plus 1. They're both really the same. One of them has parentheses and has a very explicit a value. One of them doesn't. But if you notice this, actually, this is both standard form and vertex form. I didn't really have to do much work to convert this thing into standard form. Since this isn't like an x plus 2, I didn't have to multiply that binomial together. I can just rewrite this as standard form. So I mean, how do you know that you're in standard form? Well, I can clearly see what an a value is. I can clearly see what a c value is. I don't really have a b value, so that would actually mean that b is 0 in this case. But that's okay, it's still standard form. All right, so that's those two done. Finally is factored form. And for the factored form, this is the form where it looks something like y equals a times x minus r1 times x minus r2. And remember that the r's here are the roots of the equation. So the reason why factored form is nice is because just like when you're solving quadratics, if you solve a quadratic by setting a factored form quadratic equal to 0, whatever your solutions are whatever your roots are. So in this case, I have 2 roots, and the roots are -1, 0, and +1, 0. So that means that I'm going to have a factored form equation of y equals some a times x minus -1, or I could just make this an x plus 1. And then x minus whatever my next root is, +1, so that would be an x minus 1. And actually, it turns out that I do know what my a value is still, so this is going to be negative x minus, or x plus 1, times x minus 1. And that's my factored form equation. Let me write that down here. And how do I know it's in factored form? Well, I have two factors here. I've got an x plus 1 factor and an x minus 1 factor. So those are my three forms: vertex form, standard form, and factored form.